Well, hi, and thank you so much for joining me in my shop today. I think I've reached the point where it's time to test this radio in its entirety. That would be the radio, amplifier, and the speaker. And to that end, I positioned the cabinet with the speaker in it down underneath the amplifier right here, and you can see the radio receiver there. And everything is plugged in and ready to go. So my plan here is to simply listen to this radio. Listen for things like a distortion, hum, and I check the B+ level with everything plugged in and operating and see if it's still high. Check the temperature of some of the components and do all these things ahead of a more serious alignment. Now, I'm sure all of you know the glass dial on this radio is broken, and I have ordered another one and I'm waiting for it to come, and I was hoping it would be here by now so we could install it and then finish off the radio with a alignment performed with the dial on it. It looks like the dial is greatly delayed, in fact, unfortunately. So there is a way I can align this radio properly without the dial. I may get to that. But first we got to get through this whole system test and see what this thing sounds like. I'm going to start off with just a wire antenna. We're going to go through all the bands. It's what, 9 o'clock and 10 o'clock in the morning here. Not a particularly good time for listening to shortwave, but we'll go through them anyway. Then I'll switch to the broadcast band. I'll connect my loop antenna to give it a good signal. We'll tune something in pretty strong and then listen to this thing carefully and try and make a determination if all is good at this point, or is there more out of sorts. Now the radio is probably needing of an alignment, so this test may be a little weak in the sense that for all I know, maybe the shortwave band is way out of alignment. I really don't know at this point. So let's give it a go. When I hit the power switch here, it's going to fire up for the first time in a long time all the tubes and components in this radio, including the 245 output tubes that are sitting here that have not been in the receiver the whole time I've been working with it. And then it's also going to be firing up all these tubes down here too. These ones have their own power supply separate from the receiver up here. That's a deep breath before committing myself. Okay, let's do it here. So I can also monitor the power drain, the number of watts being supplied to the radio, line voltage and everything on this guy, so we're making use of that. I also have my VTVM here ready for measuring B+ and things like that. But first, there'll be no equipment connected to the radio at all, just the outdoor antenna. Double checking, and I just realized I've got to run and flip a switch on the antenna to make sure it's actually switched into my shop here. Okay, let me just take off here for a second. Okay, I think we're ready to start. Kind of a heat run, full power. What's it sound like? How's it work at this point? Test. I'll still be using the bulbs, the dim bulbs as a restriction initially, and probably going to actually be a very large restriction because this thing's going to try to draw a lot of power. But that's how we'll start up anyway. Everybody ready? I'm ready. I am ready. Okay. You can see one of the dim bulbs right here. Any sound? Oh, sound. Oh, I almost forgot something. Okay, so I have a microphone here I really want to utilize for this test. Let me just grab it. It's going to take me a second to have it here. Set for this test. Just quickly put it here. There we are. Okay, almost forgot how important the piece here. Okay, let's test that microphone I just positioned over here. I'm positioning it in front of the a couple feet from the cabinet in front. So let's hear what it sounds like. Put on my headphones. Okay, I'll knock down all the other mics and then up that one. There we are. Okay, all sounds fine to me. Sure. Okay, back to the regular, my personal microphones now. What could happen really fast that we need to know about really fast? I don't think anything can happen really fast, frankly. Like in terms of burning out, overheating, being too much, too high, too whatever. How about the volume? Too high. Okay, so the volume is up about 10 to 15%. The amplifier down in the cabinet is a wide open amplifier. There's no volume control on it, so whatever this guy sends is gonna be maxed out in that amplifier, which we haven't powered up for quite a while. I sound very hesitant, as I should be. I should be. I don't think I've forgotten anything. Okay, so I'm going to liven up that other microphone, join the crowd here. I'm going to knock down a couple here. So now we have just two microphones going in here. One is just to my left. You can hear my voice in it. And the other one is right in front of the cabinet. I'll turn down the other one. Just making sure that the other one is set for left and right channel. Yep. Okay, I can't think of any other excuse here now, so I've just reached the point. And let's do this in a fair bit of silence too. I'm just going to turn on, I'm going to listen very carefully to everything. Maybe I'll get my temperature meter ready here. This temperature viewer has proven to be very, very useful. And not just here on radios. So I'm going to set it so that red appears on here at about 50. Let's do that. Red. Let's do it at 60. So it'll actually appear red just below 60, I think, when I do this. That's good. That's ready. Set that over there. I'm concerned about these resistors. Stop delaying, Jim. Here we go. Okay, so both dim bulbs have come on quite bright, of course. 73 volts going to the radio. That's way too low. I'm hearing a hum. Now let's just double check that hum is in the microphones. I'm going to kill the microphones here. That's right, of course. When I kill the microphones, you don't hear the hum anymore, but I hear it here in the room still. So there's a quiet hum. Let me double check here with my own ears as to what this hum really sounds like. It'll be very confusing listening to this video in terms of sound level and stuff like that. Interesting. So I've taken off my headphones and I wouldn't know there's a hum in this room. That's more than a little bit surprising in a way. I think. Certainly hear it on the headphones. Okay, next step. What are we at? We're at 69 volts, so that's next to nothing. So we're hearing a hum at 69 volts. When I raise this up now, my only option here I think is to go full tilt. 120 volts. This thing's going to really come to life, and I'm sure the hums are going to really increase. Maybe I'll hear them with my ears now. Any reason to delay? Let's check temperatures here, even though we're at 65 supply volts. Nothing is warming up. Nothing is showing up here. You have to trust me. I got the other. Don't trust me. There's no need for trust. See for yourself. All these what were hot resistors are really not showing up at all. Okay, good so far. So I'm basically going to double the input voltage here. It's at 60, it's at 70 now. When I hit the switch, it's going to go to 115 or whatever. And I think I'm going to take my headphones off. I'll leave them on. I'll hear what you hear. Here we go. So immediately there was a deeper hum. So that guy's warming up a little bit. Him too. Just a little bit. It'll take some time to build up the heat though. So currently those are only at 30, 35 degrees. That's no problem. What about these hot guys down here? Not hot. A little bit. High wattage resistors are bound to get warm. That's why they're there. You also have the magic eye plugged in. You can see that it's actually glowing fairly well. Now I'm going to check the hum level with my own ears. So I'm just walking around my shop listening. Well, there's definitely a hum there. It's quite low and it's a nice warm hum. It's a warm hum. It's definitely there. So we're running the set now on 121 volts. That's what's in my coming out of my isolation transformer. Let's put this on band. Let's turn the volume up. Is there anything there? Okay, I hear nothing. Not to jump. We'll put this onto the broadcast band, which I cleverly marked on the plate here. Boy, you know what? I don't think this thing was. I don't think it was right on the band there. Okay, volume up. Well, there you are. Okay, so I have to take off my headphones now to stop confusion. My own existence here in the shop. A little staticky. Let me turn it up a bit more. And I'm trying to set the level so I don't. So I'm trying to set the level so I don't blow your ears off or something. Let's tune. We're on the outside in town. Let's go tuning here. Okay, you can watch the capacitor. Back the other way. Hoping to pick something up down here. Okay, I'm going to adjust the treble and make sure it's turned up. What a difference there. That's the tone control. This definitely sounds like the kind of tone control that works both ends up and down, the highs and the lows. It's not just a treble cut. Put it kind of in the middle here. A little more volume. How much volume does this radio have? Lots. Lots. Check the tuning. Go for one more station. So this would be 590 sports channel. Okay, temperature check here. 65. 60. Still pretty warm, eh? Wow, just need two. So a little red, in red here, hard to see on, you can't really see it on the camera, but in red here I can read the highest temperature on the screen. You can assume it's that red spot in the resistor there. So when I read that, it's 57 there, and here it's 61, and here it's 77. It's nice to be warm. Okay, don't know if that's really a problem or not. Now, we're going to switch now to the loop antenna and try to provide a better, cleaner signal for the radio to work on. It sounds raspy right now. I think this antenna is providing this raspy signal, if you like. So we're going to, you know what? Something's smoking. Not smoking, something's smelling like it's a little too hot. Okay, so I'm going to, let's take a look at that amplifier now. Check it. What's going on here? Okay, so the big red blocks the tube. There's nothing up here to see. All the parts are underneath. 50% of your season's gains against the Boston Bruins. Wow, something's definitely getting off in the amplifier. Oh, it was very large. Let's talk about that. Talk about Morgan Riley, supposedly full start. All things Andrew Burchard's sports center, one of our favorites. Hello, Andrew. How's it going? I imagine we should do the volume just climb up and down. Yeah. Did Marcus go on vacation just before waking up early? Is that the thing? I mean, that's probably like a nice little... Well, it doesn't smell smoky. It doesn't smell like burning plastic. It just smells like hot dust. Hot dust. That's what it smells like. Believe it or not. We are doing a heat run test here. So, better intent. Better intent. Heat plus. Not back to what I was thinking. We didn't check the heat plus. I'm going to connect this meter. It may introduce a hum. The radio just did something there. Such an incredibly consistent degree that I have to triple check everything. Couldn't quite explain why hooking up my meter brown would quiet down the radio. It's a little odd. Okay, B plus, set the DC. We're on the 500 scale on this meter. B plus, we can pick it up on, pick it up right here. So down here, right at the power supply, it's 350. Okay, then a lot of these tubes, use pin 3. When I say pin 3 over there, pin 3 is a plate, I think. 1, 2, 3. Okay, well, my meter's the same. Oh my gosh, 340 volts. I think that's supposed to be 220, what I just touched. I was hoping it would go down. It didn't go down much. Oh. Well, I can't do anything about it right at the moment. I could, for safety's sake, throw the radio back on a lower, back on the dim bulb. I'll take it all the way down to 60-something volts. What's a 60? I don't think I've got the bulbs here. That's 100. Yeah, big bulbs in there. I don't have any way of powering it, around 100 volts. So, okay, we just leave it like it is. Trying to think fast. Continue with the antenna. Okay, just leave this sound while we do this. Oh, what happened there? Hold on, something funny happened there. Hold on. What's happening there? So, that's a problem. That was the antenna ground wire. You know, if I take the ground wire off, I bet you this thing will really come alive. Let me turn it down a little bit. Yeah!
Any player who puts themselves out there offensively will, have that happen to them. Unless you really sit back conservatively and never take a chance, you're going.
I don't know what happened. But that was the volume on the wire. Now we're going to listen to the loop antenna here. And the loop antenna may not be tuned to the proper frequency. There's no reason to think it is, actually. Okay, that's the ground connection. I'm going to tighten this down on the screw. This might make a little bit of noise. Maybe this will be loud. Let's see.
Stellar on-ice numbers in his career, and that's something that I mentioned that he's comparing him to, unfairly, admittedly, but, he can see that his time.
Pretty cool.
Drew Dowdy.
That's a tuned antenna, not tuned. So I'm going to tune the antenna. Let's see if I can get it on the camera.
Josh Georges and Hal Bill for Subban in Montreal.
The A camera.
Dowdy with a bunch of players.
Not particularly, but here we go.
Their names are so random, and Eric Carlson with Fleet Kuba and a bunch of players that nobody believes exist in Ottawa. So it's that level of defenseman is probably not what Riley is, and I think there's a big push last year for him.
Am I going to adjust the direction of the antenna?
Defenseman solely because of the point production. He's still a first pairing defenseman, a very, very good one, but maybe just not in that upper echelon. And I don't think that's a knock on him. I think it's just, maybe the expectations are a little bit too high.
Yeah, and not able to carry a guy like Cody Ceci. But why do you think in particular that pairing doesn't work?
Headphones back on.
I think Ceci is a player who, I don't know
So
what
he's
it
going to
is
have
about
one
him,
microphone going, the one that's listening to the speaker.
Not able to do what he thinks he wants to do. He makes a lot of bad reads. He's, not necessarily a horrible
tune the radio a little bit,
but he
see what it
has
sounds like
weaknesses
here
in
and
his
there.
mobility. He gets exploited a lot. He goes to the wrong areas at the wrong time. His defensive awareness is not very good. I think people forget that Ceci was an offensive defenseman in junior. He wasn't known to be a defensive guy, and then he got into the NHL. And the Senators were like, okay, you're going to play extremely
tone
harsh
control again?
defensive minutes against the top competition, and he just got slaughtered for years in Ottawa, and it hasn't changed in Toronto. In a small sample size, like I said, they've been very good at protecting the net front, but they can't stop passes to save their lives right now. And that's, I think, more important than actual shot location is stopping passes through the slot, and that pairing has not been very good at it. So it's something that I would be very hesitant to look at CC as a solution to any defensive problem.
Yeah.
Okay, clearly you've got to have that
the franchise knows that as well.
tone
and that's
control
why they're
kind
so
of in the
hopeful
middle to
that
get any decent
Travis
tone out
Dermott's
of it.
going to be able to return
And I'm just going to go over yonder and listen with my ears for a moment.
benefit Riley, at least defensively, on that top pairing. I know he's going to play on his off side, and we have high hopes for him, and he's looked real good at times during the regular season. Maybe not so much in the playoffs last year, but he's never played full 82 games in a season. Like, how confident are you that Dermott can be that guy that accentuates the good parts of Riley's games and Riley's game and makes up for the parts that he's a little bit lacking?
Okay.
Yeah, okay. So the one thing that I really look at with Dermott as his
switch
strength
to
defensively,
shortwave,
and
go to the high
we have to
shortwave
always
band,
consider that Dermott's been pretty darn sheltered under Mike Babcock. He's really kept him protected as much as you can protect a third pairing defenseman, which is like, less than a fourth line forward kind of thing. But
Okay, volume down. Loop antenna off. How about there? Turn on my bench microphones there. Take off the loop antenna. So far, I'm pretty happy with all of this. This is going quite well. Loop antenna off. leave the ground off for the moment. Now I'm going to switch bands. It's the biggest challenge I ever have with these radios, is how to switch the bands correctly. But very cleverly, I actually marked the AM band on the plate here, so I can't go wrong. Famous last words. Okay, I'm sure we are on the on the shortwave high frequency band. See it. So we're almost at the end of the run one way. Let me put it all the way there. Okay, now we're going to start just going through the whole band. Here we go. Getting a little quiet here. I'll just compensate with the volume. The volume's up very high now. Yeah, very curious. Like a dead spot in the middle of the band. Very, very quiet. Capacitor stopped moving right here. What happened there? It's the first time that's happened. So I probably really should be lubricating the capacitor. I know I should do that. Lubricate the capacitor and take the, so when you're turning the knob, you're not pushing a lot. You know? Everything's moving easy. Because right now I'm pushing a fair bit. So we'll do that next. Turn down here. So the whole time that band is on, the shortwave band is on, there's a little oscillation tone going. You could hear it there. A little curious about that, but not terribly curious. And the fact that we didn't pick up any stations doesn't mean much these days. Boy, I turn on my shortwave radios and sometimes there's just like 3 stations on the whole thing. It's just really, really dead. I didn't have the ground hooked up. What does that do? My experience with these ground wires and things like that when it comes to antennas is sometimes it helps and sometimes it doesn't. You just can't really figure out which way. That didn't seem to help much, did it? Doing that. Okay, so one last heat study here. Let's see, I'm not sure that this is worth even doing it on the front here. So the red things you're seeing, if you're seeing any of this, are all the tubes, of course. It's the back side here that we really want to look at. I like to look at that amplifier, which no longer has any smell to it. So whatever it was, I guess just literally burned off. Start down here, scan across. Showing up some of the wires down here. Okay, now if the radio runs for a long time, the tube sockets get hot and the heat starts coming down through the chassis. So I mean, it's starting to look a little odd here. And those two things are the tube sockets. The heat has come down through them. The bright red thing is the resistor here, and its temperature is Oh, it's got all the way up to 75. Wow. So I guess adding in all the additional load of the amplifier behind me is well, I thought the amplifier had its own power supply. It does. So why this guy's gotten so hot? Is it I just missed him all this time? 70. It's just hotter than I would want to see. So this guy too. He's at. This is probably the temperature they'll run at when you have the radio out in the open like this. But put this back in. This becomes sealed by the virtue it's sitting on a piece of wood or whatever it is. Yeah, a piece of wood. Actually, it's a piece of steel. There's a steel plate in that radio cabinet. So it's sitting on a plate of steel, and it's going to get hotter. Can't get cooler, I don't think. Can it? I don't think so. Once again, we're looking at 60 on that guy. I'm reading the red number here. 66 on him. 78. He's the winner. He's still the winner. So actually this one, and now this one down here. This guy looks like he can take the heat. This one, you know what? The paint is melted on it again. There was that photograph of another radio like this, and you could see that these two resistors both had hot spots burned into them. This has got to be a characteristic of the radio. And this one that's burned right up, that was some fault earlier. The amplifier. So the amplifier is operating right now. I could pick it up. I could turn it over while it's operating. That sounds like a dangerous thing to do. So what I'll do is I'm gonna cut the power briefly. I'll flip it over and turn the power back on. I mean, nothing's gonna cool off that fast. It's better that I not have the power on during this little process here. Really warm, and unusually warm. The tubes are very hot. Okay, there we go. Oh, I'm still recording. What? Okay, power back on. Dim bulbs first, just to keep the shock off it. Here we go. Now, I'm operating some of these tubes sideways. This is not the best way to operate them. I certainly don't want to bump them while they're hanging sideways like that. Don't bump them. But quickly, we take a look. And of course, it's the resistors there. Whoa! 100. 100. 106. And alive. Is anything else getting hot anywhere? Those are the tube sockets. I don't know if I don't know if you can see this stuff from that distance. Nothing else. Of course, there's nothing else in there. Just these resistors. Oh my gosh, those are hot. Okay, and I think we can shut her down. Let's shut it down. Okay. That kind of ends that test. So what I plan to do is just spend some time thinking about what I've seen and heard. So I have a sensible view of things now before I decide what to do next with this radio. Oh, I missed checking the magic eye. That's okay. That's an alignment issue anyway. Maybe that's what's next. We just do the full alignment here on the radio, and then it's just a matter of waiting for the dial, I think. It's not clear to me how I can cool off these resistors any further, or if in fact that is the way they are supposed to be. Maybe the ones in the amplifier, I put those in myself. I can probably do something to spread them out, to try to calm that down a little bit, because 100 degrees, and And the very last thing I'm going to do, because you've probably noticed that this 78 record sitting here on top of the on top of the cabinet. Now, I'm just showing you this. I just learned this a little while ago, and I was quite surprised. I went through my 78s, and I found one that has no grooves here on this part, and no grooves here. So that means this record was pressed somewhere around 1920, somewhere in that range. And it also means this was made without any electronics. So that means the music on here was done live into a cone, and the cone attached mechanically to some kind of cutter cut the master that eventually made this record. So no electronics involved. So if you've got some old 78s, I would suggest you quickly look for ones that have no groove in here, and then look more closely at them. You've got something that you may not realize you have, just like me. I just assumed all these records were using, vacuum tube equipment to make them, but this actually predates that. Cool, eh? Imagine you had to yell, you had to sing or yell at the right level to get the cut right on the record. I mean, it must have been quite a challenge to do these. That actually sounds pretty good, for an old record. Thought I'd show you that because I got a little excited when I discovered I had one. The rest of my 78s all have the grooves. So thanks a lot for watching, and I'll now go away and think about all this stuff for a while, and we'll come up with our next step along the way with this radio. Thanks a lot for watching.